Alright, now on to part 2, same problem. So we found the cost of removing 90% of the pollutants. So now find the limit as C goes, find the limit of C as P goes to 100 from the left and interpret its meaning. Well, first of all, we want to understand that the only way we can approach P of 100 is from the left, because the percent can't be greater than 100%. Or we can never remove more than 100% of the pollutants. So the limit as P goes to 100 from the left of 80,000 P over 100 minus P. Well, let's think about what this is going to be. Well, what is happening at P equals 100? Well, at P equals 100, we have a vertical asymptote. Therefore, I know that the limit I'm looking for here is going to be a descriptive limit. So, if I approach from the left, well, that means I'm going to plug in a number a little bit less than 100. So if I plug any number in close to 100 in the numerator, it's going to be a positive value. If I plug in something in the denominator that's a little bit less than 100, and as I keep getting closer to 100, the number gets smaller, but it still is always going to stay positive. So this is going to be infinity. This should make sense if we interpret its meaning. So what is this telling us? So think about that. What does it mean that as the limit of P goes to 100 from the left, the cost is going to infinity? Well, we want to understand what is the cost representing. It's the cost of removing the pollutants. So this is saying the cost of trying to remove all the pollutants will become infinitely large. Another way to say that is it's impossible to remove 100% of the pollutants. The closer we get to removing 100%, the larger the cost will become, and it will become large very quickly. Okay, next one. According to the theory of relativity, the mass m of a particle depends on its velocity v. M sub 0 is the mass when the particle is at rest, and c is the speed of light. Find the limit of the mass as v approaches the speed of light from the left. So I want you to pause the video and try to answer this limit. Unpause when you're ready to check your work. Alright, so here, if I approach c from the left, if v approaches c from the left, I apologize. So the numerator is always going to be a positive number, assuming the mass is positive of a particle, which it should be if it's a particle. Now, if I plug in numbers for v that are getting really close to c, this number is getting really close to 1. However, it's still going to always stay less than 1. So if this number right here is going to get really close to 1 but still stay less than 1 because v is going to stay less than c, the denominator is going to stay positive, and I get positive divided by positive, which is going to be infinity. And I know that I was looking for a descriptive limit because when v equals c, that is going to be a vertical asymptote. Alright, so now I want you to find two functions f and g such that the limit as x goes to c of f of x equals infinity, and the limit as x goes to c of g of x equals infinity, but the limit as x goes to c of f of x minus g of x does not exist. There are many correct answers. Pause the video, unpause when you're ready to check your work. Alright, so the example I came up with is the limit as x goes to 0 of 1 over x squared is infinity, so that's my f of x. The limit as x goes to 0 of 1 over x to the 4th is also infinity. That's my g of x. The limit as x goes to 0 of 1 over x squared minus x to the 4th is negative infinity. It is not 0. There are other correct answers. this is the example that I came up with. I also apologize. You may or may not notice that the writing is getting a little bit sloppier. My stylus has stopped working, so I have to write with the mouse now. Fortunately, there's only one more example. So, on to that last example. I want you to evaluate the limit as x goes to 4 from the left of x squared minus 16 over x minus 4, and the limit as x goes to 4 of x squared minus 16 over x minus 4. Pause the video, unpause when you're ready to check your work. Alright, so this one's a little bit tricky because of the absolute value of x minus 4 in the denominator. So if I factor the numerator, it becomes x plus 4 times x minus 4 over the absolute value of x minus 4. Now you might think that those would just cancel and I get x plus 4. And that kind of happens. Not exactly though. So as I approach 4 from the left, x plus 4 is going to approach 8. X minus 4 is going to approach a very small negative number. Absolute value of x minus 4 is going to approach that same number, but it's going to be positive. So these two things right here are basically going to become negative 1. Since they're going to have the same value as x gets close to 4, but this one's going to be negative, this one's going to be positive, so negative divided by positive is negative 1, since they're the same value. This is going to approach 8. So the limit as x goes to 4 from the left of this function is going to be negative 8, because it's basically negative 1 times 8. This function, if you graph it, this piece of the function is going to be the same as negative x minus 4. It's going to look like that line. So when you graph this function, to the left of 4 is the line negative x minus 4. To the right of 4 is the line x plus 4, because the same thing's going to happen here, except for now when I put in numbers very close to 4, but to the right, this term is going to be positive. This term is going to be the same value and positive. So these two divided by each other will become 1, and then this will become close to 8. So the limit as x goes to 4 from the right is going to be 8. Therefore, the limit as x goes to 4 does not exist, because from the left it approaches negative 8, from the right it approaches positive 8. Funny side note, I realized after I told you, sorry for the writing getting sloppy, that you probably don't notice a difference. I just noticed that it's more of a pain to write with a mouse. Anyway, conclusion. If the evaluation of a limit results in plus or minus infinity, that's a descriptive limit. The actual limit does not exist, but we use the descriptive limits now. So don't write does not exist, write infinity or negative infinity. When evaluated limit as x goes to positive or negative infinity, think about the end behavior. So it's going to approach a horizontal or an oblique asymptote. That's the end of our notes.